in my last video, we have discussed the 4 points in the classification of elements and periodicity in the properties synopsis, right? Next, we will continue with the fifth one. Fifth point is periodic trends in the properties of elements. Periodic trends in the properties of the elements. This is the next point we are going to discuss here. Now, we will discuss one by one. We have to discuss atomic radius, ionic radius, ionization enthalpy, electronegativity, electron gain enthalpy, etc. We will discuss one by one. First, we will start with the atomic radius. Already we have completed this one in the theory classes, and also I will repeat here, atomic radius. Now, here, atomic radius along period, this mark indicates left side to right side, that is period. Along period it decreases, and along group it increases. Just remember that one. Atomic radius decreases along period and increases along the groups. Now, for example, if this one is the periodic table, just check. If this one is the periodic table, now here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? This is the second period elements. Just check: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Second period elements means here from lithium to fluorine size goes on decreases. Lithium to beryllium, beryllium to boron, boron to carbon, carbon to nitrogen, nitrogen to oxygen, oxygen to fluorine, size goes on decreases up to halogens. After halogens the size increases. This you should have to remember. Means the size of halogens are more than that of the size of the, here lithium to fluorine size goes on decreases from halogens. After halogens the size increases. Means the size of the halogens is lesser than the size of the noble gases. Means noble gases size will be more than that of the halogens. 18th group element size will be more than that of the 17th group elements in that particular period. Not in all the periods, in that particular period. Now that is only I am writing. Size of halogens in particular period. In only one period you have to compare, is smaller than that of the size of the noble gases. Size of the noble gases. That is only here. Size of the halogens in particular period is lesser than that of the size of the noble gases in that period only, right? Next, we will go for the second one, B. That is ionic radius. Ionic radius. Here it is also very same as that of the atomic radius. It will here it will again decreases along period and increases along group. Ionic radius also decreases along period, increases along the group. Now just check here, one very important point is there. Very important point. I am putting star here. Just remember what is that one. For example, here I want to use the rough paper. Now if A is the parent atom, its size is, for example, 5 centimeter. Not exactly I'm taking, just roughly for more clarification I'm taking one general example. If A is the one of the atom whose size is 5 centimeter, A plus is its cation, A minus is its anion. Plus means cation. Plus means what? Cation. Its size is 4 centimeter. A minus 1 means its anion. Its size is, for example, 6 centimeter. It is just basic example, not particular example. For more clarification, I am taking this one. If A is the parent atom, then A plus is the cation and A minus is the anion. Means the size of cation is smaller. Size of cation is smaller than that of the parent atom, and the size of anion is greater than that of the parent atom. That is only I am writing here. That is only I am writing here. Particular point for size. For size, always cation size is smaller than that of the parent atom, and it is smaller than that of that particular anion. This is very important point, just remember. Next, another very important point. It is also very important, and another very important point is, this is also very important. Actually, this is very important. We know isoelectronic species are isoelectronic species. What is meant by isoelectronic species? The species which are having same number of electrons are called as what? Isoelectronic species. Now this is the size rule for isoelectronic species, for only isoelectronic species. Isoelectronic species. How the size will changes, we will discuss now. I will write the rules first. After that we will discuss examples. Now here, what are the rules is size for cation, size of cation. How it will change is, the rule is charge on cation is inversely proportional to the size. Means when the charge of the cation is more, then size will be less. For isoelectronic species, this is for isoelectronic species, isoelectronic species only. Example we will take, particular example we will take here. Now for example, here Na plus Al plus 3 Mg plus 2. Arrange its size in increasing order. Right, what is the question? Arrange the size of Na plus Al plus 3 and Mg plus 2 cations in increasing order, or smaller size to larger size. Now we will see already what we know the rules is. These are isoelectronic or not, just check here. Na atomic number is 11, plus 1 means remove 1 electron. How many electrons are there? 10 electron. Aluminium atomic number is 13, plus 3 means remove 3 electrons. Then the number of electrons left 10. Mg atomic number 12, plus 2 means remove 2 electrons. How many electrons are left? 10. Now all are isoelectronica because here Na plus has 10 electron, Al plus 3 has 10 electron, Mg plus 2 also has the 10 electrons. These are isoelectronic. For isoelectronic and also all our cations are positive charge, positive charge, positive charge. Then apply this rule, right? Charge on cation is inversely proportional to the size. Means more positive charge, smaller will be the size. Smaller will be the size. Means more the positive charge on the atom, smaller will be the its size. Where the positive charge is more, Al plus 3, therefore it is having smaller size, very smaller size. Al plus 3 has very smaller size. Why it is having very smaller size? Because plus 3 charge, right? Charge is more compared to plus 2 and plus 1. Plus 3 will be the more charge, therefore it is having smaller size, right? Next, after this one, more charge, right? Over next, which is having small, very larger size. very larger size means smaller will be the positive charge. Here Na plus has very larger size, because here only +1 charge is there. +3 charge means very smaller size, +1 charge means very larger size. In these three examples, in between Mg+2 is there, means larger the charge on the cation, smaller will be the size. Inversely proportional. Larger charge on cation, smaller will be the size. Inversely proportional. That is only I wrote. Al+3 is there, more will be the positive charge, smaller will be the size. Right, here +1 compared to +2 and +3, +1 is a smaller positive charge, therefore it has larger size. It has what? Larger size. Just remember this one. It is increasing order. Decreasing order size is Na plus smaller positive charge, therefore larger size. Mg+2 little larger positive charge, smaller size. Al+3 has more positive charge, therefore very smaller size. In this way, this is the rule. Right, I will write the order for this one. Na plus size is greater than Mg+2, which is size is greater than Al+3. Why? Because of charge on the cation. Higher the positive charge, smaller will be the size. Smaller the positive charge, larger will be the size. Over. Next, second, size of cation over. Next we will discuss size of anion. Size of anion. It is also only for isoelectronic species. Now here I will write the rule. Charge on anion is directly proportional to the size. Means higher the negative charge on the atom, then more will be its size. More will be its size. This is the rule. Means as the charge on the anion is increases, size of that ion also increases. That is only we are discussing. Now just to check here, I will take one. Let us check here. N-3, O-2, F-1. Now just to check. N-3. Nitrogen atomic number is 7. Nitrogen atomic number 7. -3 means gain of 3 electrons. Gain of 3 electrons. Total number of electrons 10. O-2. Right. Oxygen atomic number 8. -2 means gain of 2 electrons. Total number of electrons 10. Fluorine atomic number 9. -1 means gain of 1 electron. Total number of electrons 10. All are having 10 electrons. N-3, O-2, F-1. All these ions are having 10 electrons. Therefore, all are isoelectronic species. All are isoelectronic species. Now, if he is asking what is the order of size, increasing order of size, then just remember, smaller the charge on the anion, or more the charge on the anion, more will be the size. F-1, only -1 charge is there. O-2, -2 charge is there. N-3, -3 charge is there. F-1, only -1, negative charge is smaller. Therefore, smaller will be the size. Next, O-2, here it is. Fluorine has -1 charge, oxygen has -2 charge. -2 charge, more negative charge. Therefore, more will be the size. Less negative charge, therefore less will be the size. Next, again here N-3, here again more negative charge, therefore it is having larger size. Larger size means when the negative charge on the atom increases, size also increases. For cation it is opposite. As the positive charge on the atom increases, size decreases. As the positive charge on the atom increases, size decreases. Here as the negative charge on the atom increases, size increases. Right, that is only I am writing here. Negative charge on the atom increases, size increases. F-1, O-2, and the last one is N-3. Right. Next we will discuss one question here. Question. Na plus F-1, O-2, N-3, Mg+2, and Al+3. Right, here what he is asking is arrange these ions in increasing order of size. Increasing order of size he is asking. Now just to check answer. Just to check here, what are the given elements? Na plus F minus 1, O minus 2, N minus 3, Mg plus 2, and the last one is Al plus 3. Now all are isoelectronic or not? Just check here. Isoelectronic or not? Just check. Na plus atomic number 11 plus 1 means 1 electron remove 10 electrons. Fluorine atomic number 9 minus 1 1 electron add 10. Oxygen atomic number 8 minus 2, right? Therefore 10 electrons. 7 plus 3 10 electron. 12 minus 2 10 electron. 13 plus 3 means what? Remove 3 electrons, therefore 10 electrons. All are having how many electrons? 10 electrons. Therefore all are isoelectronic species are isoelectronic species. I told already, for isoelectronic species which is having very very smaller size, the one which is having higher positive charge, right? Which is very very smaller size, the one which is having more positive charge, more the positive charge. Here it is, charge on cation is inversely proportional to size. As the positive charge increases, the size decreases. More the positive charge, lesser will be the size. Therefore Al plus 3 has higher positive charge, therefore it is having very very smaller size. Next, which one is having very larger size? Which one is having very larger size? Size increases with anion, right? The higher the negative charge on the atom, then the size will be the more, that is more negative charge. Means how to write the order? From higher positive charge to higher negative charge. First we will write the cation order for cation, because cations are having smaller size than that of the anion, right? That is also read on here. Another rule, cation size is lesser than anion for isoelectronic species. It is also for isoelectronic species. Therefore the correct order is which one is having very smaller size? The one which is having cations only having the smaller size. Just remember, in the isoelectronic species, cations only having the smaller size. In the cation, again, which one is having smaller size? The one which is having larger positive charge. More positive charge, smaller size. Next, again here, Mg plus 2. Again here, Na plus. Cation size over. Here it is. Plus 3 means more will be the charge on the cation, therefore it is having smaller size, right? In this way. Next, for anion, which having the smaller size? The one which is having smaller negative charge, therefore F minus 1. Next, O minus 2. Next, which one is having very larger charge? The one which is having more negative charge. Means this is the order. This one is the order of size of cation to anion for the isoelectronic species, right? Now just remember, you have to write size from cation to anion. Just remember, you have to write the sizes from cation to anion. More cation or more or larger positive charge, that is larger cation to the larger anion. You have to remember, more positive to more negative, you have to write in this way order. More positive to more negative, you have to write the order, and it will be the increasing order, not decreasing order. It is increasing order. More the positive charge, very very lesser will be the size. More the negative charge, very very larger will be the size. In this way you have to write the order. Now next we will go for the third one, C, that is ionization enthalpy. Next, A B over, next to C, ionization enthalpy. Here I am using which one? Red pen. C. Ionization enthalpy. What is going to be ionization enthalpy? Amount of energy required to remove the outermost electron from an isolated gaseous atom, right? Now already the definition or the things we have discussed in the theory classes only. Now I want to write how it will vary first. Before that one, I will discuss what is meant by first ionization enthalpy, what is meant by second ionization enthalpy, etc. First ionization enthalpy or ionization potential means, first ionization enthalpy, ionization potential, both are same, right? Now first ionization potential means what? Here it is, energy required to remove first electron from isolated gaseous atom. In the given atom, if you want to remove the first electron, you should have to apply some energy. That energy required is called as what? First ionization potential. In a given atom, if you are removing the first electron, the energy required for removing that first electron in the isolated gaseous atom is called first ionization potential. For removing the first electron in an atom, energy is required. That energy is called first ionization potential. Second ionization potential means, again here, just check here. Second ionization potential means energy required to remove the what? Second electron from the same isolated gaseous atom. Here also, second ionization potential means amount of energy required to remove the second electron in the same atom. Amount of energy required to remove second electron in the same isolated gaseous atom. In the given atom, for removing the first electron, the energy required is called first ionization potential. In that same atom, the amount of energy required to remove the second electron is called second ionization potential. Now just remember this one. Again, it increases. It is opposite to that of the atomic radius. How it will vary? Opposite to that of the atomic radius. Here, along period, it will increases. Along period, ionization potential energy increases, and along group it will decreases. Now here, very important point here. Already we know that. I will give the hint also. First we know that half filled, completely half filled orbitals present means it has more ionization potential. If the atom has completely half-filled orbitals, then it has more ionization potential, or higher will be the ionization enthalpy, right? Similarly, completely full-filled also. If completely full-filled orbitals are present, again it has a very high or more ionization potential or ionization enthalpy. Completely half-filled, completely full-filled orbitals, if they are present in the atom, then it is having more ionization potential. Just remember this one, right? On this basis only. Now just to check, for example, if this one is the periodic table, now second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now, just you think that along period the ionization enthalpy will goes on increases. Already I wrote here only, along period the ionization enthalpy goes on increases. If you think that along period the ionization potential goes on increases, then the order will be, if you are writing lithium is having smaller ionization potential than beryllium has lesser ionization potential than boron has lesser ionization potential than carbon. In this way, in this order, if you wrote, it will be wrong. It will be completely wrong, because just check here, beryllium to boron, I am taking two elements, beryllium and boron. Now for second period, ionization enthalpy for second period, I will write here. If you think that lithium, what are the elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? This is the elements of second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Second period elements. This is period means ionization potential goes on increases. If you write in this way order, it is wrong. It is wrong order. It is not correct order. Why? Because here I will take the few elements, beryllium and boron. I will take beryllium and boron. Here beryllium atomic number is 4. Here it is hydrogen, helium, lithium, beryllium. Atomic number is 4. And the boron atomic number is 5. Beryllium atomic number is 4 and boron atomic number is 5. Correct? Here it is. Beryllium atomic number is 4, boron atomic number is 5. What is the electronic configuration of beryllium? 1s2, 2s2. Right? Boron electronic configuration 1s2, 2s2, 2p1. And already we know that s means 1 orbital, p means how many orbitals? 3 orbitals, d means how many orbitals? 5 orbitals, 1, 2, 3, 4, 5. F means how many orbitals? 7 orbitals, 1, 2, 3, 4, 5, 6, 7. Now s means how many orbitals? 1. P means 3 orbitals, d means 5 orbitals, f means 7 orbitals. That we have discussed in the structure of atom quantum numbers synopsis. Right? Now here S1 4 means 1s2, 2s2 electronic configuration. Here atomic number 5 means electronic configuration 1s2, 2s2, 2p1. Here 1s, s means how many orbital? 1. Again s means how many orbital? 1. Here 2 means all the orbitals are completely fulfilled. Right? Here in the beryllium the orbitals are completely fulfilled. In the boron 1s2, here 2s2, 2p1, the orbitals are not completely half-filled, completely fulfilled. Right? Completely half-filled is also not there, completely fulfilled is also not there. Here 2 orbitals are empty. Therefore this beryllium has completely fulfilled orbitals. Therefore it should has the more ionization enthalpy than the boron. Here the mark will become reverse for beryllium to boron, because beryllium has completely fulfilled orbitals than the boron. Therefore beryllium has more ionization enthalpy than the boron. First correction over. Next we will go for the nitrogen and oxygen. Second, here let it be here only. Now I will take another rough paper. Here nitrogen and oxygen. Nitrogen atomic number 7, oxygen atomic number 8. Right? Nitrogen electronic configuration 1s2, 2s2, 2p3. Oxygen electronic configuration 1s2, 2s2, 2p4. Now for outer shell I am taking here only. Right? Now just check. Here s means how many orbital? 1. P means how many orbitals? 3. Right? Here again s means how many orbital? 1. P means how many orbitals? 3. Now just check. Here 2s has how many electrons? 2 electrons. P has how many electrons? 3. 1, 2, 3. Hund's rule. First, no pairing. When all the orbitals should get the singly occupied or 1 electron. Right? Because all are having same energy. Here again 2s, 2 electrons. 2p how many? 4. 1, 2, 3, 4. Now just to check. Here this is completely half-filled. Here 2p orbital is completely half-filled. 2s is completely fulfilled. Now just check. Here it is completely half-filled. The orbitals in the nitrogen atom are completely half-filled, whereas in the oxygen there is no completely half-filled and completely fulfilled. Here 2p last, it is not completely half-filled, it is not completely fulfilled. There is no completely half-filled, completely fulfilled. Therefore, because in the nitrogen the orbitals are having completely half-filled, with the electrons, therefore this nitrogen has higher ionization enthalpy than the oxygen. Second correction is in the nitrogen to oxygen, even though they are in the same period, right? Ionization enthalpy will in not this order, in this order. Nitrogen has, here it is, nitrogen has more ionization potential than the oxygen. Why? Because nitrogen has completely half-filled orbitals. Then what is the order? Now what is the correct order? What is the correct order? I will write here. I will write correct order of ionization potential for the second period elements. What is the correct order? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. right? Here this is the period, means ionization enthalpy increases. Lithium to beryllium increases, but beryllium to boron decreases. Why? Because beryllium has completely full-filled orbitals, therefore it is having more ionization potential. Therefore it is having what? More ionization potential, right, than the boron. Again it is period, means increases, but nitrogen to oxygen ionization potential energy decreases, because nitrogen has completely half-filled orbitals. Here completely full-filled orbitals for the beryllium, therefore it has more ionization potential than the boron. Here nitrogen has completely half-filled orbitals, therefore it is having more ionization potential than oxygen. Again remaining order is same, right? But the changes is beryllium to boron and the nitrogen to oxygen, reverse arrow should be there, because beryllium has completely fulfilled orbitals, it has more ionization potential, and here nitrogen also has the completely half-filled orbitals, therefore it has more ionization potential. Therefore the correct order is this one. Similarly, right, now I will take another rough paper here. Now similarly, just to think, for the third period, here beryllium, boron over nitrogen, oxygen over. Similarly in magnesium and aluminum, magnesium to aluminum, this is the period. Along period ionization enthalpy what happens? Increases, means aluminum should have more ionization potential energy than the magnesium. Aluminum should have more ionization potential than the magnesium, but it is not happening. It will be reverse. Magnesium has more ionization potential than the aluminum because of completely fulfilled orbitals in the magnesium, right? Therefore again magnesium has more ionization potential energy than the aluminum. Next, last one is between phosphorus and sulfur. Again these are belongs to the phosphorus. Sulfur belongs to the period means sulfur has more ionization potential than the phosphorus, but it is wrong. Because phosphorus completely half-filled orbitals, sulfur there is no completely half-filled and completely fulfilled orbitals, therefore phosphorus has more ionization potential than the sulfur. If you think only in the periods, only along the periods, phosphor should have the less ionization potential than the sulfur, because along period ionization potential goes on increases, right? If you think in that one, it is wrong, because phosphor has completely half-filled orbitals, it has more ionization potential than the sulfur. This is over, right? Now these 4 hints you have to remember. How we have to remember? I will give the best hint, right? Now just to check, best hint is, what is our best hint? Here beryllium, boron, nitrogen, oxygen, magnesium, aluminum, phosphorus, sulfur. These 4 elements you have to remember, or 4 here. 4 you have to remember, because these all are having completely half-filled or full-filled orbitals, therefore these are having more ionization potential in this way, right? Now how to remember, sir? This one very difficult, sir, right? For this one I will give hint. Now here Be means beta ba in Kannada, right? Some parents are calling to his son in Kannada. I will explain the hint. Be means beta, B means ba. Here it is No means no, beta ba no. Now here it is. First I will take please mingle agala, right? ಹಿಯರ್ ಇಲ್ಲೇನಂತ ಹೇಳ್ತೀನಿ ಅಂದ್ರೆ ಕನ್ನಡನಾಗ ಹಿಂಟ್ ಹೇಳ್ತೀನಿ ನಾ. ಏನಂತದ ಅಂದ್ರೆ ಇದು ಬೇಟಾ ಬಾ ನೋ ಪ್ಲೀಸ್ ಮಿಂಗಲ್ ಆಗಲ್ಲ. ಅವ್ರ ಒಬ್ಬರ ಮಗ ಸಿಟ್ಟಾಗ್ಯಾನ, ರೈಟ್? ಪಾರ್ಟಿಗೆ ಬರ್ಲತಿಲ್, ರೈಟ್? ಮುನ್ಸ್ಕೊಂಡನ. ಅವನಿಗೆ ಪ್ರೀತಿಲಿಂದ ಅವ್ರ ತಂದೆ ಏನಂತ ಕರೀಲತ್ತಾರ ಅಂತಂದ್ರ ಬೇಟಾ ಬಾ ನೋ ಪ್ಲೀಸ್ ಮಿಂಗಲ್ ಆಗಲ್ಲ, ಪಾರ್ಟಿಗೆ ಬಾ ಅಲ್ಲ ಅಂದಪ್ಲೆ, ರೈಟ್? ಅದೇ ಹೇಳ್ತೀನಿ, ಬೇಟಾ ಬಾ ನೋ ಪ್ಲೀಸ್ ಮಿಂಗಲ್ ಆಗಲ್ಲ, ರೈಟ್? ಹಿಯರ್ ಆರ್ಡರ್ ಹೆಂಗ್ ಬರೀಬೇಕು? ಈ ಟೈಪ್ ಏನ್ ಹಿಂಟದ? ಬೇಟಾ ಬಾ ನೋ ಪ್ಲೀಸ್, ಪೈಲೆ ಪ್ಲೀಸ್ ತಗೋರಿ, ಇದಕ್ಕೆ ಥರ್ಡ್ ಬರೀರಿ, ರೈಟಾ? ಇದು ಫಸ್ಟ್ ಬರೀರಿ, ಇದು ಸೆಕೆಂಡ್ ಬರೀರಿ, ಇದು ಥರ್ಡ್ ಬರೀರಿ, ಇದು ಫೋರ್ತ್ ಬರೀರಿ. ಬೇಟಾ ಬಾ ನೋ ಪ್ಲೀಸ್ ಮಿಂಗಲ್ ಆಗಲ್ಲ, beta ba no please mingle ಆಗಲ್ಲ ಈ ಟೈಪ್ ನೆನಪಿಕ್ಕೋರಿ ರೈಟಾ. ನಾವು ಹೆಂಗೆ ಬರೀಬೇಕು ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, beta ba no please mingle ಆಗಲ್ಲ, ರೈಟ್. ಈ ಟೈಪ್ ಬರೀಬೇಕೀಗ. ಕ್ಲಿಯರ್, ರೈಟ್. ನಾವು ಸೆಕೆಂಡ್ ಪೀರಿಯಡ್ ಆರ್ಡರ್, ಥರ್ಡ್ ಪೀರಿಯಡ್ ಆರ್ಡರ್ ನೀವೇ ಬರ್ಕೋಬೇಕು. ಇದು ನೋಡಿ, ರೈಟ್. ಯು ಓನ್ಲಿ ಹ್ಯಾವ್ ಟು ರೈಟ್ ದಿ ಆರ್ಡರ್ ಆಫ್ ಅಯನೈಸೇಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಫಾರ್ ದಿ ಸೆಕೆಂಡ್ ಪೀರಿಯಡ್ ಅಂಡ್ ಥರ್ಡ್ ಪೀರಿಯಡ್, right. Now, then also I will write the second period ionization potential order here. What is order is lithium, second period lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Lithium, this is period. Period means along period what happens to the along period what happens to the ionization potential? Increases, right. This is the second period ionization potential increases, lithium to beryllium, but beta bano reverse, right. No, here it is no, again reverse. This is the correct order of ionization potential. Here it will be reverse, here it will be reverse, beta ba no, right. For third period I will write again order, third period. Now third period elements are what are the elements? Third period elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and the last one is argon. Now if you think that this one is period, along period ionization potential increases, if you write in this way all, right, then it will be wrong. If you write all in this way it will be wrong. Just remember mingle agala, right. Therefore reverse here, right. Magnesium has more ionization potential than aluminium. Here please also there on our hint, beta ba no please, right. Phosphor, sulfur, therefore phosphor has more ionization potential than sulfur. This is the best hint. You have to remember these compulsory for writing the order of ionization potential for second period and third period. He will give in the question, right. Write the correct increasing order of ionization potential for second period elements. He will give 4 options. This option should be correct. Write the correct increasing order of ionization potential for the third period elements. This order is correct. Don't think that along period continuously increases. That is wrong. Completely half-filled more, completely fulfilled more. That also you have to remember. Clear? Now another one more very important point is here. Very important point. In the periodic table, helium has very high ionization potential. In the periodic table, which element has the very high ionization potential? Your answer should be helium. Helium has very high ionization potential or ionization enthalpy. Ionization potential or ionization enthalpy. This completes your ionization enthalpy. Next we will go for the next one, electronegativity. Now next I will take another paper for electronegativity. C or D? D. Electronegativity. What is electronegativity? Capacity of an atom to attract the shared pair of electrons in a covalent bond, right. Now we are not interested in the definition here, we are interested in the order, right. How it will changes. Again along group, along period, along group, right. It is exactly opposite to that of the atomic radius. Along period it is increases, along group it is decreases. Or now just check what is the order. First remember, most electronegative element in the periodic table is fluorine. Fluorine is the most electronegative element in the periodic table. Next most electronegative is oxygen. Next most electronegative is nitrogen. Just remember phone, not phone. Here phone means fon. This is the order of electronegativity in the periodic table. It is for not group and period, right. It is for periodic table. In the periodic table, what is the electronegativity order is? Most electronegative element in the periodic table is fluorine. Fluorine is the most electronegative element. Then most electronegative element is oxygen. Next most electronegative element is nitrogen. This is the order. And also you have to remember the another hint, right. Phone. Here this is the hint, phone, right. Next we will go for the electron gain enthalpy. Next E. Electron gain enthalpy. Here it is also same, opposite to that of the atomic radius along period, increases, left side to right side period increases, group decreases, group decreases, and it will be negative values. It is in negative values. What is meant by electron gain enthalpy? Amount of energy released when 1 mole of electrons added to the isolated gaseous atom, right? Always negative values. Now just think, don't concentrate on the sign, you have to check only on the number, right? Now just a sign indicates it is releasing. Now here almost all elements has negative electron gain enthalpy, but noble gases has positive electron gain enthalpy. This is also you have to remember. Elements, almost all elements have negative electron gain enthalpy, but noble gases has positive electron gain enthalpy. And one more thing, very important point is hint. It is only for p block. Hint in the electron gain enthalpy only. Hint is for p block, for only p block. The second element in the group, second element in the particular group has more electron gain enthalpy than the first element. Second element in the particular group has more electron gain enthalpy than the first element. That is the point or the hint. Now for this one I am writing, just to think, I will take here 16th group. What are the elements? Oxygen, sulfur, selenium, tellurium, polonium, right? This is the 16th group. Now I will write here 17th group. What are the elements of 17th group? Already you know, full color, brightness in atom, right? Fluorine, chlorine, bromine, iodine, etc. Right? Now just to check, order is, this oxygen is first element in the 16th group, and sulfur is second element. Therefore sulfur has more electron gain enthalpy than the oxygen, right? Next here in the 17th group, chlorine is the second element and the fluorine is the first element. And chlorine is second element. Therefore chlorine has more electron gain enthalpy than the fluorine. Therefore here for 17th group the order is, it is very important, very important. Order for the electron gain enthalpy for the 17th group is, chlorine has more electron gain enthalpy than the fluorine, then bromine and iodine. Means reverse order you have to take. Chlorine second element, therefore hint for p block elements for electron gain enthalpy, second element has more electron gain enthalpy than the first element. Here second element is chlorine, therefore it has more electron gain enthalpy than the fluorine. Next fluorine to bromine to iodine. This is the order: chlorine, fluorine, bromine, iodine for electron gain enthalpy. Here it is somewhat different. For 16th group somewhat different. Sulfur has second element, that is sulfur has more electron gain enthalpy. Next element, there is no oxygen, there is selenium, right, tellurium and polonium, and the last one is oxygen. Least electron gain enthalpy in the 16th group. Oxygen has least electron gain enthalpy in the 16th group. The question is, in the 16th group which element is having the least electron gain enthalpy? Your answer should be oxygen. In the 16th group which one is having the more electron gain enthalpy? Your answer is sulfur, right? What is the order of electron gain enthalpy for 16th group? Then sulfur, right, has more electron gain enthalpy than selenium, then tellurium, then polonium. The last one is oxygen. For 17th group, what is the order? Second element, that is chlorine, has more electron gain enthalpy than the fluorine, then the bromine, then the iodine, and this is the order. Next, very important point here I will write, very important, right? The chlorine is the most electron gain enthalpy element in the periodic table. which is the most electron gain enthalpy element in the periodic table? Which one is having very high electron gain enthalpy in the periodic table? Your answer should be chlorine, right? Here fluorine is most electron gain enthalpy element in the periodic table, and electron gain enthalpy is also called electron affinity. Electron affinity, right? Which is the most electron gain enthalpy element or electron affinity element in the periodic table is chlorine, right? Now next we will go for the another one. Next only few points are left, simple points. For that one I am using another paper. Now directly I will write here E over F. That is, no, F is metallic and non-metallic character. Metallic and non-metallic character. Just remember, I will write directly for metallic, along period metallic character decreases. Left side metals, right side non-metals. Left side metals, right side non-metals. That we know already. Left side metals, right side non-metals. Therefore, along period metallic character decreases, along group metallic character increases. Metallic character increases. For metallic character, along period metallic character decreases, along group metallic character increases. Now for non-metallic character. For non-metallic character, it is opposite. Along period non-metallic character increases, non-metal will comes, therefore increases. Along group non-metallic character decreases. Now always metals means basic in nature, non-metals means acidic in nature. Means when these metals combines with the metals, when they combines with the oxygen, they forms basic oxides. Basic oxides. When the non-metal combines with the oxygen, they form acidic oxides. Acidic oxides. Metals basic in nature, non-metals acidic in nature. HCl, Cl is there, acid. Cl non-metal, acid. NaOH, sodium, metal is there, therefore it is a base in this way, right? Now next shielding. Again one more point I will write here. Note, electronegativity is directly proportional to acidity, right? More electronegativity means more will be the acidic nature, and electronegativity is inversely proportional to the acidic nature. That is, less electronegative means less will be the acidity. More electronegative, more will be the acidity, right? Now here it is not acidity, here it is basicity. Sorry, basicity. Electronegativity is inversely proportional to the basicity. More electronegativity, less will be the basicity. Less electronegativity, more will be the basicity, right? Now and the last point here, last note, very important, that is shielding effect order. Shielding effect order. Shielding effect order is, already you know what is the shielding effect order. S has more shielding than P, then D, then F. This is the order of shielding effect. S, P, D, F, decreasing order. S has more shielding effect than P, P has more shielding effect than D, D has more shielding effect than F. This is the order of shielding effect. This completes your synopsis on the classification of elements and the periodicity and properties. We will stop here only. Thank you.